A 10-gram bullet is fired at 3 different stationary blocks, each with a mass of 5 kilograms, but each made out of a different material, such that the motion of the bullet after hitting the block is different for each one. In trial 1, we have a block, and when the bullet hits it, it's going to pass right through it and come out on the other side. Now, the block would have made it slow down a little bit, but it still passes all the way through and comes out on the other side. In trial 2, the bullet hits the block and then just bounces off it, so it's going backwards. And in trial 3, the bullet becomes embedded within the block. So we want to, in part A, rank the 3 trials according to the resulting speed of the block after the collision, greatest to least. And this is based on conservation of momentum, which is however much the momentum of the bullet changes by, the momentum of the block will change by that same amount. So if the bullet doesn't change its momentum by that much, then the block's not going to change its momentum by that much. So if you think about trial 1, the bullet passes through the block. It's slowed down a little bit, but not enough to stop it or to even reverse its direction. So in trial 1, there was a pretty low change in momentum compared to the other 2 trials. So trial 1, I'm actually going to rank as number 3 because the momentum of the block doesn't change that much, which means it only picks up a small amount of speed. Let's go up to trial 3. In trial 3, the bullet becomes embedded in the block, which means the bullet had a bigger change in momentum because it actually caused the bullet to stop moving, or at least stop moving relative to the block. It's still moving because now it's in the block and they're moving together, but that's a bigger change in momentum than it was in trial 1. So trial 3 is ranked as number 2. And then for trial number 2, where the bullet bounces off the block, that's actually a huge change in momentum because keep in mind that momentum is a vector, so it has positive or negative depending on the direction. If the bullet hit the block, there was enough momentum to stop the bullet and to reverse its direction into the negatives. So that's a big change in momentum, which means the block is going to have a big change in momentum or a big gain in speed. So trial 2 is going to be the block with the greatest speed. So in part B, now we're just going to do the calculations to kind of show that this ranking is true. So in each case, the bullet's moving at 500 meters per second, and the block is stationary just before the collision, and we want to calculate the resulting speed of the block for each of the 3 trials, given this little bit of extra information. So in B part 1, it says the bullet emerges from the block on the other side, moving with a speed of 200 meters per second. So it entered the block going at 500 meters per second. It came out of the block moving at 200 meters per second. So we're going to set up the conservation of momentum equation for B part 1, which is M1 V1 initial plus M2 V2 initial equals, now after the collision, the 2 items are not stuck together. The bullet's not embedded in the block, so we're going to leave it as 2 separate terms. M1 V1 final plus M2 V2 final. Check to see if any of those terms go to 0. This first term is the momentum of the bullet initially, and it is moving when it hits the block. This second term is the momentum of the block initially, which is stationary. So we can say that whole thing is 0 because it has no velocity. This is the momentum of the bullet after the collision, and it's passed through the block. So that's not 0. This is the momentum of the block after the collision, and since the bullet has passed through it, it's caused the block to start moving slightly. And that's what you're trying to figure out for this. What is the value of V2F? So it's a pretty simple algebra equation now, because you know M1, the mass of the bullet. Just remember that you have to convert the bullet's mass into kilograms. 10 grams is 0.01 kilograms. You know the initial velocity of the bullet. You know again, this is the mass of the bullet. This is the final velocity of the bullet, the 200 meters per second. This M2 is the mass of the block, so you can solve for the V2F. And you should get an answer that is less than 1 meter per second. I won't tell you the exact answer because I want you to try and figure this out on your own, since it's pretty basic math. In B part 2, this is where the bullet bounces off the block and moves backward with a speed of 200 meters per second. So it turns out to be the exact same equation as above, M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final, where once again the initial momentum of the block is 0 since it was stationary. You're still trying to solve for the same thing, the V2F, which is the final speed of the block. In fact, everything in here is exactly the same as the last question. The only difference now is the final velocity of the bullet, instead of being 200 meters per second, this V1F, that final velocity of the bullet, is going to be negative 200 meters per second because the bullet's going in reverse, which is the negative direction. And when you plug all those numbers in and solve for the answer, you should get a number somewhere between 1 and 2 meters per second. It's going to be a decimal number between 1 and 2. And then for part 3, this is the one where the bullet becomes embedded in the block. So this time we're going to have to use a slightly different equation. The M1 V1 initial plus M2 V2 initial equals, now the bullet being inside the block is just one item combined, the bullet and the block combo, which has a mass of M1 plus M2 times the velocity of the bullet and block combined, which we're just going to call VF. And same as before, the initial velocity of the block is 0 since it's stationary. We're trying to solve for the resulting speed of the block, which is the speed of the bullet block combo, the VF. So plug in all the same stuff for here. The mass of the bullet, the 0.01, plus the mass of the block, which was the 5 kilograms. So this mass right here is 5.01. And when you solve for that velocity, you should get a final answer of something that's very close to 1 meter per second. In fact, it's so close you can just round it to 1 meter per second. And then what you see is that in trial 1, this was the one that had a number less than 1 meter per second, so it was the slowest, which is why it was ranked as a 3. This was one that was ranked between 1 and 2 meters per second, so it was the fastest, which is why it was ranked as the number 1. And then the last one, this is the one that came out to be really close to 1, so it's in the middle, which is why it was ranked as the second place.